Looking forward to hear more about it.
Thank you.
Welcome, Fergus.
Thanks. So, this is an introduction to Search Index JS. I'm going to try and pitch it kind of deep, but not too deep. So there's quite a lot of code in the slides, which I'm not going to demonstrate. I'm going to talk a little bit about, but hopefully this presentation can be used as a reference afterwards if you're interested in developing concepts on Search Index, or if you want to just work out how things are screwed together. Yep. So I am Fergus McDowall. I'm a technologist and an idealist. As you've probably guessed, and as I was introduced, I'm Scottish, but I've sort of lived all of my adult life in Norway because completely randomly, when I finished university, I got a job at Kelku.com, which became Yahoo Product Search, and they were based in Norway at that time for 15 years ago. So I've worked a few years in academia. At one point I was the CTO at Findexa, which is the Scandinavian telephone directories. My day job is now as a consultant working with search technology. So I work at Compedio. We have this really narrow sort of niche, but we kind of work at all the sort of the big government agencies and sort of organizations in Norway. I'm also the co-founder of the Oslo Bike Kitchen and Biverkstad. So we're trying to open up like an open makerspace in Tøyen, so that's a really great project. Support it. Here to talk about Search Index and Norch. How many people here are familiar with or have used Solr, Elasticsearch, FastESP, or another sort of search server? So I guess that's maybe like about a third or a half. This was definitely something which was really niche a couple of years ago. And now that Elasticsearch is something that you can actually use, it's become a lot less niche. But this project started with Norch, which was an attempt just to make a really easy, usable search server, because when we started, like 2 years ago, that was just before Elastic had got all the sort of funding and all the development effort that they have now. And at that point, really search engines were difficult to get set up. So when we realized how cool and easy the NPM network was, we thought, hey, it would be really cool if you could just do like an NPM install Norch and get like a search index up and running. But like as we sort of developed the technology, we realized that like, okay, like Norch, that's cool and everything and it works. But actually it's search index, which is kind of like the core. That's like a kind of synonymous with like maybe Lucene, but except it's much more simple. That was kind of the thing that had become like a little bit more interesting after a while. And what's kind of interesting with what we found out was that because Search Index is built with on level DB, it's like it's isomorphic. So that means that it can run on level DB. It can also run on index DB, which is in web browsers. So we found out that actually Search Index is really platform independent. One little thing to say is that in some ways Search Index goes against the kind of philosophy of Node.js because it's really quite a big module. But the API is fairly sort of compact. So it should probably be at least maybe 3 modules, but at the moment it's 1 module. So it's based on the LeBron stack, which is Level, Browserify, and Node.js. This is something which has been covered, I think, in the last 2 WebRebels in some depth. So many wonderful things are still to happen on this stack. So I really, really like it. But I think it's still, I get the impression it's still a little bit of a kind of a niche thing that maybe not a lot of people know about. So I would definitely, maybe that's incorrect, maybe it is a very well-known thing, but I would encourage people to to explore this stack because it's really interesting, and it ties in really closely to what Dale was just speaking about relating to developing offline web applications. It's really fast for large key value sets, and it's quite platform dependent yet close to the metal. So if you are familiar with Solr and Elasticsearch and FastASP, this is what your stack probably looks like, where you've got like a big sort of all the magic is happening in the server, and you've got clients sending search queries to the server and reading returned responses. This is the new Hotness, and of course the thing here is that actually the architecture is just the same, but sort of different things are happening in different places. So the new Hotness is that like less magic is happening on the server because servers are just like they're acting more like sort of content delivery networks. So of course networks are magic. There's a lot of caching that happens on networks, and this is why things like Imager and other content delivery networks can make money, because they're not actually delivering files for every request. They're just saying if files have been changed or not. And then if they haven't been changed, generally you'll actually get the file delivered from a cache somewhere in the network, if it's your local proxy, if it's a router a little bit higher up, if it's maybe even higher up than that. So yeah. And another thing that we've noticed in our work as search consultants is that there's a lot of talk these days about big data, maybe like a year ago especially, it was like a really kind of like hot thing to talk about. But what we notice about, even with some of our kind of quite big and established clients, is they very rarely genuinely have like big data. They've often got data sets that are in the order of maybe like sort of 50,000, maybe 100,000 documents. So actually small data is really what most people are using quite powerful search engines for. And probably it's kind of overkill. So love small data, embrace small data. You probably need a small data app. In case you don't, in which case call me. We'll fix it for you. Perfect. Okay. Yeah. So these are the GitHubs that you need for making small data apps, small data search apps. This is Search Index and Norch. And this is what you're going to have to do with your data. So probably you're going to have like some sort of like unstructured data, which can be anything, any sort of format, like Word documents, can be a database, it could be like, anything. Then you need to convert it into some sort of JSON format. Then you need to make the JSON into some sort of format that your search engine understands. And then you can index it. So when you're document processing, like I'm not really going to go too in depth into this, but I'm just going to say like Lodash is really good for document processing. So if you're doing a lot of looping, if you're doing a lot of sort of manipulation of JSON objects, then definitely check out Lodash. That's a really cool thing. So one thing you might want to do if you're making like if you've made the decision that like, okay, I don't have like a massive amount of data, and like I do all the rest of my work in like Node and JavaScript, and this is like the language that I understand, that I'm comfortable with. You might make the decision that, oh, I'm not going to use like a big Java application server. I'm going to just make a standard HTTP server that uses Norch.js. So if you want to install Norch.js, given that you have Node and NPM and everything set up, this is all you have to do. So you just do npm install Norch, and then run Norch, and then that's how you index some data. So, and if you do that, then, why can't do I have to do this? Is that what I have to do? Where's my, oh, there, of course. No, it's on the wrong screen. This is all going horribly wrong. How do I, oh God, if I minimize it, and then if I move it there, no, there, is that? Oh my God. There we go. There we are. Okay, so that's in the, let's see, if we go like boom, No, sorry. Oh God. Let's see. Okay. We'll go like this. Phew. There we go. Okay. So you've done npm install Norch. I'm not going to do npm install here now because it's too scary. I don't know what the network's going to do. But then you're going to end up with this node modules directory. So you want to go into node modules, you want to go to Norch, you want to go to bin, and then Norch. And then, of course, oh, that's really weird. My God. Okay, anyway. And then if you go to your, Jesus. I'm totally. I don't even. What the hell is? Okay, you know what? This is gonna be an exercise for the audience to explore the wonderful world of Norch by yourself, because I'm just not going to be able to get this to work. I don't think. Can I at least get my slides back? How? If I do control. At least unminimize this. There we go. Come on. No. What's the unminimized shortcut for? Command-Shift-F. Why is that not working? Apple Q? Boom. There we go. Jesus. Okay. The demo gods are not with us today, which is probably a good thing. Okay, well, anyhow, you can do that, and your Norch will start, and it will be really good, and it will make your life wonderful. And once you have your Norch up and running, imagine, if you will, an API service that you're sending HTTP requests to, get a really nice, well-formatted JSON back from. You're going to probably want to set up like an Angular front end. There's a sort of a bare bones app here that you can use, and all you do is you just like download it, and that will give you the really basic sort of bare bones thing that you need to set up like a test search app for a Norch server. And also there's some test data there that you can load up, and then you'll have like a really nice Elasticsearch type search app. But you've not had to go through the pain and suffering of installing Java and setting your Java home and buying a big server on Amazon and all that sort of stuff. So you will still like your life because this will be on Node, which is really good. You could also just make a Node.js app. So Norch is that's the kind of the HTTP wrapper around Node.js. So that's just like a total standalone server. But you might have already like a Node.js app, and you just want to like drop some sort of search functionality into your Node.js app that's already running. In which case, you might want to do something like this. So what we're doing here is we're just we're installing search index. So you're doing the require at the top is like requiring search index, and then you're like sort of adding like a batch of data. And then if you want to sort of search in your data, you just do SE search. So it's like a really simple, really basic, typical, the Node way of doing things that we all know and love with callbacks. So the big advantage of, so this is just like a really kind of simple way of doing things. And of course, the big advantage of this is you can make your own cool server-side applications. And I guess also that's the disadvantage, that this is a server-side application, because kind of the real sort of magic of search index is that you can now write indexes that replicate over to the client and then work offline. So there's a lot that you can do with this. I'm going to walk through a couple of examples. There's a lot of different ways that you can look at this as well. But is this like madness? Like, should you actually even attempt to make an offline search index? And it turns out that actually this works quite well. So it runs on all browsers, and it's noticeably smooth. So once you sort of replicate an index into the browser and you start typing, there really is like no latency at all. So it's a really nice, smooth user experience. Search indexes have generally got a lot faster recently. So if you have a Solr, if you have an Elasticsearch, even if you're on like SharePoint or something, actually this is something which is improved generally. But it's only going to get so good because you've always got to send that request to the server. Often the query is quite a big lump. You've got to get like a JSON back, and often the JSON is a real monster. So you're always going to have this kind of late latency when you're dealing with like a kind of query response to a server. But if everything's client-side, it actually works really, really well. Another cool thing which Dale was sort of mentioned really in passing is that it's actually persistent. So once you replicate a search index to a client, then even if you like close your browser, shut off your computer, go away, make a cup of tea, come back again like the next day, open your computer, open up that same domain again, then your search index is still going to be there. So that's really cool, and that like opens up like a lot of possibilities. Again, as Dale was mentioned, there's a lot of challenges to do with like syncing. There's a lot of things you have to think about when it comes to like adding deltas, which is like adding the difference of all the updates. So instead of like replicating the entire index every time, like actually just like sort of putting on the newest parts of the index. And you probably will really notice if you do this that server costs are lower. Like we have at work, we always have like a kind of test Elasticsearch up and running on Amazon. And even though it's like a test version and it's not really doing like a massive great deal, I think we're paying like sort of $1,200, $1,500 a month to keep that up just for a really basic version. So although it's much cheaper to run everything in the cloud these days, there is actually still quite a big cost if you're going to have like clusters of kind of relatively powerful servers. So network caching is magical. The net's getting faster, so just like sending over like a big lump of like replicating an entire index is getting faster and faster all the time. And the user experience, of course, is really nice because there's no latency and everything's really slick. So there's a few different ways that you could approach this. Like one thing that you can do is that you can actually add data client side. So what we're doing here is we're actually indexing, so running the indexing procedures. So there's basically two sort of ways that you could approach like building up like an index in your web browser. You can either index all the stuff that you have in the web browser itself. So maybe like you've got some sort of user input, like the user is like typing in some sort of like to-do list, or maybe like sort of typing in like lists of something. And you want to add these to an index and generate and maybe persist that index on the user side. So if you were wanting to do that, then you would do it. In this kind of way. So the big sort of advantage of this is that you wouldn't have to kind of like speak to the server to update your index. But of course, the big disadvantage with it is that you have to index lots of documents, because with search technology, actually, having quite a fast search is relatively trivial, but having fast indexing is often quite tricky. So you really want to kind of, you can do this, there's advantages to doing it this way, but you maybe want to sort of think about not doing the indexing yourself. This is kind of like a cooler approach. So what we can do here is we can actually like pre-generate like indexes for a given data set, and then we can like replicate the entire data set into the browser. And I always think a really good analogy for this is like a podcast. So, and podcasts are actually something that are becoming really popular just now. It's like there's a renaissance in podcasting. And I think a lot of people are into this idea that, like, yeah, they're going to let their phone sync when they're at home or when they're at work or when they're somewhere with a net where there's like good net, and then they're going to like listen to their podcast when they're on the go. But you could, I mean, that could be the same for anything. That could be the same with like a little kind of like, a classified sort of Craigslist or Fin.no app. It could be the same with like, some sort of dating application or something where you have to like download a big data set, and then maybe you want to look at it when you're on the go, when there's not necessarily network. And again, I would sort of echo that point that in Norway, man, we're so spoilt because there's just fantastic internet like everywhere, at least in Oslo. But it's not like that, everywhere. So this is this idea that you can like pre-generate indexes and then sort of like put them out, allow people to sync them to their devices when they're on like a strong network, so that they can like then go back and use its applications when they're roaming around. I think that's a really strong idea. So another thing which you can do, which is sort of kind of like mad science, but not really, is that you can like index from all sorts of stuff that's running in the browser. So there's a really cool demo here, which I'm just too scared to even attempt because the demo gods are not smiling upon this presentation at the moment. So, but anyway, this is in the GitHub repository. So if you clone the searchindex.js thing, there's a whole directory of examples, which are fairly kind of easy to understand. But I'm just going to have to take my word for it. It's really easy to index a PouchDB instance, and all you do is you just do db all docs, and then you do se for search index, so se add, and then you just add the whole array of docs that you got back. And one little thing here, and the stuff at the top is like a document processing function. So like one difference, for example, between PouchDB and CouchDB for that matter, and search index is that the ID field in CouchDB is like underscore ID, whereas in search index it's just like ID. So there's like a little thing there that kind of renames the ID field, and it specifies which fields in that data it's going to take. So here it's only taking title, body, date, places, topics, and it's dropping everything else that was associated with those documents in the PouchDB. So this is kind of like a cool, this is a cool little thing to check out. And incidentally, one thing that I should have mentioned is if you want to work this, you have to if you want this to work, you have to browserify it, of course. So you use the Browserify command. So, but this is all really sort of well. So I would encourage people to, if you're interested in this, go to GitHub and look at the examples. So that should be, and it's fairly straightforward. And do open an issue or reach out to us if you need some like help or sort of any kind of advice with it. So there is that's the address to the examples. So if you're indexing things, you have to put things, so if you want to index things into your search index or your Norch, you have to use this format. And the whole point about this format is it's like just super simple. So every document is an object, and every object is a key value, and this object here is like an array, and that's because that's metadata. So, and obviously you can filter a metadata, you can do aggregations on the metadata as well. So, this is like when you search for a house on Fin.no, and then you've got all the sort of the stuff in the left-hand column, which is like all the kind of the metadata. there's a batch format, which is just an array of objects. So it's really easy. There's no kind of magic. You just like make an array, and you can index objects one at a time, or you can index like an array of objects, and that will work. Just a word on numeric sorting, because one of the big sort of really cool things about search index is that it doesn't have any sort of types in it. So you don't have to specify if a field is like a date, or if it's an int, or if it's a string. Because search index just assumes that everything's a string. So that makes it, in some ways, like quite easy to do stuff. Generally, I think that you save a lot of effort on like not having types, but one sort of consequence of that is that everything will be sorted alphabetically. So you can't sort numerically. So if you want to do stuff like this, like have like number ranges, and like then kind of sort the number ranges, you actually have to express your numbers. You have to pad out your numbers and express them as strings, so that when you sort them alphabetically, they will be sorted numerically. So you have to put all the zeros before the number. And here's a nice little function for doing that. So if anyone is interested, you can have that for free. There you go. I love you guys. No, sorry. Okay, so working with queries, getting stuff out. So, and here's like another thing, which is like, it's kind of like I personally think this is an advantage. I totally understand if some people would think it's a disadvantage, but the thing is that it's really simple. So it's like a really simple query language. You can, you're saying query on the field, and then this array is like the array of tokens, and it's always and. So there's none of this kind of messing around with like sort of or queries or weird logic that most of your users probably don't understand anyway, although sometimes you might have a need for that, in which case use something else. But here it's just like everything's and. So it's always like I'm searching for Africa Bank, so give me all the documents that contain Africa and bank. You can also query on titles. So we speak a lot about sort of precision and recall. So you can make more precise queries that have less recall, that will give you less back. Or you can have queries that are more vague, which will return larger data sets. And you can also sort of split up. So here we're saying, I want to search for, I want all documents for the title is Africa and the body is bank. And incidentally, you can also weight. You can add a weighting to each field, so you can say that the hits in title are more significant than the hits in body. So you can actually build up fairly useful relevancy models if you want to. Here, we've increased the recall by like just searching for star and star, which will give you just everything in the database, which is total recall. It's like, okay, yes, moving on. So facets. If you want to do, and this is how, you make that left-hand column where it's saying that, you've got 12 houses that cost between 1 million and 2 million kroner. So this is how you would specify ranges. You can also just, if you don't specify ranges, if you just have like total amount and then like an empty object, then it will aggregate everything on each individual price that it has. So generally speaking, if you're dealing with like aggregation on numbers, it's quite good to use ranges. If you're dealing with aggregation on metadata, it's generally you probably wouldn't want to use ranges. And you can also you can sort your facets, you can limit your facets. There's a couple of other kind of magic things that you can do. And of course, when you click on a facet, then what you're doing is you're filtering. And this is how you would filter. And this is really kind of simple functionality, but it's also, again, what we find in our work is that mostly this is the functionality that really solves like 90% of what our customers want. So it doesn't have to be more complicated than this. You're going to make the vast majority of people happy with like filters, facets, weighting, like field weighting, field search. you can do some other stuff as well. So this is like, you can specify the page size, you can specify, the offset. You can make a little teaser, which is that little, if you search for something in Google, you get this little sort of text preview that shows your search words in the document. That's what a teaser is. And you can also use weight to create relevancy models. I can't hop out and show you the results, but there's a really beautiful, nice, pretty JSON that shows you all the hits, shows you your query. So it's the point that I would sort of make is, again, like everything's quite lean. Like it's very sort of like you're not getting like search indexes giving you back like quite a lean result set. It's not very big. And of course, you can use anything you want to parse your results. So I'm a big fan of caveman JavaScript. I try to understand Angular, and I think I feel like I guess maybe a lot of people feel like they're doing stuff in Angular all the time, but they don't really kind of understand it fully, or they could maybe always understand it a bit better. You can do this. You can just parse results in any possible way that you see fit. One of the things that we've put a lot of effort into in Norch and Search Index is replication. And there's a good reason for this, which we might possibly talk about at the end. So one of the cool things about Norch is that it's really replicatable in a sort of nodey, streamy way, which is really sort of pleasing. So once you've made an index, once you've indexed everything, it's really trivial to then duplicate that index or save it. And you can duplicate it to like another. Here we're using Norch, so you could duplicate it to another server. You could also duplicate it to the client, so you could replicate your server-side index to the web browser that was visiting, if you wanted to. In practice, you probably wouldn't want to hit the replication endpoint, which is the snapshot endpoint. You probably wouldn't want to hit that, because then you're actually generating the mirror every single time. So what you would probably want to do is just make the file and then make the index backup file and then like serve that on a content delivery network, so that you're not so it can be cached. You're not like generating it every time. We haven't explored this feature very much for making clusters, so the potential is definitely there. But I personally have not done very much work there. And as far as I know, I don't think anybody has. But this certainly opens for some quite nice clustering possibilities, because it allows you to make. First of all, you can split the index up into shards using a load balancer, and then you can duplicate each index. And there's also replication in searchindex.js, and this is the way that would work. So, and again, it's quite straightforward process. So here are the strengths and the weaknesses of the system. And I'd say, I've written some stuff here. I'd say probably if you're going to use it in Angular out in the wild, maybe the biggest sort of pain thing you're going to come across is like a performance lag for like quite large data sets. So if you're going to like try and replicate like a super big data set into somebody's browser, you'd want to think carefully about like how you were going to do that, because probably you're going to create some kind of pain for the user. So we're working a lot on trying to make the index files smaller. So just now, there's a lot of things that make indexes take up a lot of time, to take up a lot of space. For example, like the ability to delete documents, the ability to search on individual fields, faceting, filtering. Like if you just decide that like, I actually don't need those things at all, then you can save like 90% of your index size. So the next iteration of search index is going to have much smaller files for replication. But on the strengths, it's super portable. It really does work everywhere. it's really easy to install and use. It's literally, if you're in the browser, you just have to include, you browserify an application, and you just include it in your script tag, and then you've got like a search index in your browser. If you're going to make if you're going to install Norch, it's just like ridiculously easy. It's like npm install Norch, and it's up. It's actually quite performant for simple queries. So if you have simple queries on small data sets, I don't think there's any search engine that's faster than Norch. Obviously, it's not really made to scale for like big data. So there is a point at which like you're going to want to use something else. But if you're using if you've got quite small data sets, which often you maybe are, and this would be like in the order of under like 50,000 documents, then probably Norch is quite okay, or Search Index. And it runs on really low-end hardware. So IndexedDB is everywhere now. It's definitely in the last version of iOS. I think it's in Android. It works on like Linux, Mac, Windows, everything. It's and it really doesn't use that much memory. So you can run this on the people have been running this on like Raspberry Pis, and it runs really well. And I'd say the weaknesses are that it's really strictly for small data. There's quite a limited feature set, but I guess in some ways that's a strength as well, because this is really simple. Like anyone can just pick this up and start using it if you're reasonably familiar with Node. And there's a relatively small community compared to other search technologies, which have recently become very popular. So Elastic is very popular. Solr is undergoing a renaissance, so I would encourage everybody to revisit Solr, because that's actually the latest version, has got a lot of really nice functionality. And actually, the latest version of Solr is doing some of the same things that we're doing here, especially with queries, which is that they're just making the query language and query construction really simple. So they're kind of, in a way, taking away functionality. They're making it much more elegant. So, and this is future direction, who's speaking a little bit about this. Richer query syntax, better docs examples, perhaps a service for generating indexes, maybe. Better compression, mad science, performance and bug fixes and that sort of thing. And another thing which we think would be really cool is open search. So this is this thing where if you're in a browser and there's you can choose your search provider. So you can choose, I want Google, or I want Yahoo, or I want DuckDuckGo, or you can make your own open search sort of server thing. It would be really cool if the open search could point to an index on the page. So you could say, browser, when I use the search box, now I want to search in this page. So that would be really good. Please get involved if you want to hack. We accept basically everything. We have very low standards, so this is kind of it's sort of like a wiki, almost, as it should be. And nobody's done anything on iOS or Android yet. So that would be really cool if somebody, so that would be really interesting to see if that actually works. Yeah, so thank you for listening. I'm sorry about the demos, but they probably weren't that interesting anyway, and they're on the net, so you can go and find them yourselves. But thank you for just now.
Thank you. Please join me in this lovely... Is it green or blue?
Oh.
The couch.
It's turquoise, is it?
Turquoise?
I think it's different in the shade. It's very green in the shade, and there's also a nasty stain on the bottom of that cushion.
Okay. Good.
If this sofa could tell a story...
They flipped it. You know what? That story might not be safe for
might not be good for
general
That's
consumption.
for afterwards.
So I have some notes here about some questions that are nothing to do with the couch.
Oh.
A little bit to do with the pouch. PouchDB, is it big in Scotland?
We're all about the pouch in Scotland. Yeah. Yeah, we get pouch in primary school. We start in primary 3. Then we get pouch until primary 5. Then we move on to couch.
Right.
Yeah.
Okay. So pouch is for kids, really.
Well, no, I wouldn't say that. It's so important that you have. It's the first. It's like you guys have to learn English, in first edition. So it's like it's the most important thing. You have to, yeah.
Yeah. So there's a couple of questions coming here. One of them is basically, what's the support for access rights? Is there any way of doing that?
Yeah, there's a really cool way to do it. It's not actually in this software itself, but Mats Olsen is giving a really good talk about this at NodeConf on Saturday.
Okay, cool.
So there is a really simple and easy way that you can make, an effective way that you can really lock down your web services that works for anything which has got an HTTP JSON sort of interface.
There's another question about whether you can do incremental index updates on the client and the server.
Yes, if you are indexing on the server, if you're indexing, not if you're replicating. So if you're replicating, it's all or nothing. If you're indexing, then you can add like individual documents. You can replicate an entire index and then like index some documents on top of that if you want to. So that would work fine. But this idea about making deltas is something that we're still working on.
Right, because this is still a work in progress, isn't it?
This is a work in progress. This is definitely, it's like a hobby project, and it's something which, we've kind of picked up and sort of put down and, gone away and sort of thought about it for a while and come back to it. So it's definitely a hobby project. We maybe have one customer that's expressed a little bit of interest in it.
So that's exciting.
In a bank, a Norwegian bank, or at least a Scandinavian one. So for this one little niche thing. So and that incidentally is related to the problem in inverted commas of paying for big clusters. So these clusters they quickly cost a lot of money, and for some use cases you can't really defend the amount of money that it costs just to have the uptime on a big server farm, particularly if there's personalization involved, because personalization creates a massive data set, because basically you have to duplicate the search index for every single user of the system.
Right, yeah, that would take up space pretty quick, wouldn't it? So where do you want to take this next then? I know you talked a little bit about it. What's the mad science that you're thinking about?
So a lot of people would look at this project and think, well, why bother? Like I have my Elasticsearch, I have my Solr, I have my fast ESP. Actually, nobody would say I have my fast ESP. Why bother? But they might say I have my Solr, my Elastic, or my something else. And the thing about humanity, just to take up a level, is that now we are totally dependent on search indexes. Like we have this like hive mind, and we're completely dependent on search technology for our memory, for our we have this little robot in our pockets that tells us who to mate with, where to go, what to do, and that's fine. I think that actually, I think we could have a philosophical discussion about whether, we should have self-determination or whether we should be ruled by the robots. But I think most of us would agree that, I quite like the utility of this technology. I do want it. But what maybe a lot of people are less comfortable about is the idea that this search technology is owned by, one company, basically. There's one company that kind of owns this hive mind. So, in a real sense, and without wanting to sound completely paranoid, because, that's not, this is not, but okay, but to sound completely paranoid about this, that's kind of bad. And I think the one company that we have in mind that maybe, I don't know what company you're thinking of, I don't think we're speaking about a specific company, but we could say that this company at the moment is run by people who seem to have a relatively sound moral footing. They seem to be running in a good way, but that won't always be the case, and that it will be, it'll change ownership in 20 years, and so there's a real need for a distributed search index that's not really owned by anybody. It should be possible with the technology that we have to make an index that kind of lives everywhere and lives nowhere, and when that index comes around. It will probably be, it might not, it probably almost certainly won't use searchindex.js, but it will use small composable replicatable, portable search indexes. So there is a need to have search indexes that can be distributed across the entire network and that don't just live on the servers, but also live on like the nodes around about the place. And I think that with some combination of like small composable indexes, some kind of torrent protocol, some kind of blockchain to handle versioning and transactions, I think that like a distributed search index is definitely achievable. So that would be kind of like the end goal. That's like that's the why should we even care about making portable search indexes.
That's a really awesome vision. Thank you, Fergus.
Thank you.